This is section 10.2 on arithmetic sequence and series. We have the sequence 3, 7, 11, 15, 19, comma, keep on going in that pattern forever. And what makes this an arithmetic sequence is we add the same amount every time. So 3 plus 4 is 7, add 4, that's 11, add 4 to that one is 15, and so on. To find the common difference, we take any two consecutive terms and we subtract them. So we can take 3 and 7 and subtract those. 7 minus 3, that's 4. Or we could take 7 and 11. We could take 11 minus 7, and that's 4, and so on. And all of those should be 4 if this is an arithmetic sequence. So the common difference, D, is 4. Find the next 4 terms. Well, we start with 19 and add 4. That's 23, and then we have 27, 31, and 35, and we get each of those by just adding 4. Find the explicit formula for an arithmetic sequence. Let's start out with the first term. A sub 1 is 3. And really, we've added nothing. We've added 0 times 4 to get the first term. But then the second term, we can take the first term, 3, and add on 1 4. Then to get the third term, we could start over with the first term again, take the first term, and add on 2 4s, which is 8. So to get the third term, which is 11, we could start with the first term and add on 2 4s, which is 3 plus 8, and that gives you 11. To get the fourth term, we could again start with the first term, 3, and now add on 3 4s. And to get the fifth term, we could start with the first term and add on 4 4s. Notice that to get the second term, we add on 1 4. To get the third term, we add on 2 4s. So the amount of 4s we add on lags behind the nth term by 1. So on the fourth term, we have 3 terms, or we had 3 4s. So a sub n is equal to, we'll take the first term and add on n minus 1 times the common difference. So this right here, that's what you need to know. That's the explicit formula for an arithmetic sequence. The recursive formula is, well, tell me where it starts. A sub 1 is 3, and then a sub n is equal to, we'll take the term before and add on the common difference. Example 2, explicit and recursive formulas. Find the first term of the arithmetic sequence for which a sub 25 equals 139, and the common difference is 3 4s. Let's start with the explicit formula. A sub n equals a sub 1 plus n minus 1 times the common difference. Well, a sub n in this case is a sub 25. It's the last term, and we're told that it's 139. So we write 139 for really a sub 25. That's equal to a sub 1 plus 24. That's 25 minus 1 times the common difference, which is 3 4s. Then we have 139 is equal to a sub 1 plus 24 divided by 4 is 6, and then 6 times 3 is 18. So we have 18, and then we just have to minus 18 from both sides. So the first term is 121. Find the 68th term of the arithmetic sequence 25, 17, 9, keep on going. Well, a sub n is equal to a sub 1, that's 25, plus n minus 1 times the common difference. If we take 17 minus 25, we get negative 8. So each time we're adding on negative 8 to get the next term. This is negative 8. We are asked to find the 68th term, so a sub 68 is equal to 25 plus 67 times negative 8. Turn that on. 25 plus 67 times negative 8. And that's equal to negative 511. So the 68th term is equal to negative 511. Example 2, explicit and recursive formulas. Find the first term of the arithmetic sequence for which a sub 25 equals 139 and d equals 3 4s. Let's start out with the explicit formula. A sub n is equal to a sub 1 plus n minus 1 times d. The 25th term is 139. A sub 1 is what we're trying to find, And then the n is 25. 25 minus 1 is 24. And the common difference is 3/4. We have 139 is equal to a sub 1 plus 24 divided by 4 is 6, times 3 is 18, and then we minus 18 from both sides. A sub 1 is equal to 121. On the second problem, find the 68th term of the arithmetic sequence. So a sub 68 is equal to a sub 1, which is 25, plus 68 minus 1 times the common difference. And the common difference is 17 minus 25, that's negative 8. So times negative 8. So a sub 68 is equal to 25 plus 67 times negative 8. We have 25 plus 67 times negative 8. And that's equal to negative 511. So a sub 68 is equal to negative 511. If two non-consecutive terms of an arithmetic sequence are known, the terms between them can be calculated. These terms are called arithmetic means. In the sequence below, 17, 27, and 37 are the arithmetic means between 7 and 47. So in this sequence, negative 3, 7, 17, 27, and so on, we have the numbers 7 and 47. And the arithmetic means in between them are 17, 27, and 37. Write an arithmetic sequence that has 4 arithmetic means between 4.3 and 12.8. We'll start out with 4.3. And we'll write 4 arithmetic means in between. In other words, 4 values. 1, 2, 3, and 4. And then the last number is 12.8. To get from 4.3 to 12.8, we added on a common difference once, twice, 3 times, 4 times. We added on the common difference 5 times. Let's take 12.8 and minus 4.3. That's 8.5. When we added on the 5 common differences, the total of all those was 8.5. So we take 8.5 and divide it by 5. That's 1 times 5 is 5. We'll subtract. That's 35. We added on 1.7 each time. So now we just add on 1.7. We have 6, 7.7. Add on 1.7. That's 9.4. Add on another 1.7. That is 10.1. Excuse me, not 10.1. But that would be 11.1 when we carry the 1. And then add on another 1.7, you get the 12.8. So there's the sequence. Write a sequence that has 6 arithmetic means between 12.4 and negative 24.7. We have 12.4 as the first number. 1, 2, 3, 4, 5. 6 numbers in between, and then negative 24.7. Now we added d on 1, 2, 3, 4, 5, 6, 7 times to get from 12.4 to negative 24.7. So we take negative 24.7 minus 12.4. That's equal to 37.1. And then take 37.1. It's actually negative 37.1. So we'll take negative 37.1 and divide by 7, which is, let's see, we got 5. That's 35. Subtract. Ignore the fact that that's minus, really. And then we have 21. That's 5.3. Now that's negative 5.3, so we minus 5.3 each time. Let's take 12.4 and minus 5.3 a few times. And there's your first 3 numbers. We have 7.1, 1.8, and negative 3.5. Let's do that a few more times. We're minusing 5.3. And we get negative 8.8, negative 14.1, and negative 19.4. An arithmetic series. An arithmetic series is the indicated sum of the terms of an arithmetic sequence. So if you have the arithmetic sequence, -7 or -6, -3036, then the arithmetic series is, well, you take those terms and you add them up. Let's say we have the sum of an arithmetic series. We could have the first term plus the first term plus the common difference. That would be the second term, plus the third term, plus the fourth term, and keep on going until you get to the very last term. Well, then what we could do is take the very last term and add on the one right before that one, and then add on the one right before that one, because now we're subtracting. So we're going from the last term all the way down to the very first term. Then when you add these two together, you get 2 of the s sub n's, and then you get a sub 1 plus a sub n. And then you get a sub 1 plus a sub n, and these two cancel each other out. And that happens over and over and over again. Well, you have an n amount of these, so all of those add up to n amount. And then you just divide by 2, and you get the sum of an arithmetic series right there. There's the formula. Now, we've seen that before if you were present in class. We had, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we wanted to find the sum of those numbers. We could take 11 plus 11 plus 11 plus 11 plus 11. And we could find the sum that way. Well, really what we did is we took the first term, a sub 1, we added on the last term, a sub n, so that's the 1 plus the 10. And since we took them in pairs, there are 5 of these. There are 10 divided by 2 of those, in other words 5. So we could take 5 times 11, and that's equal to 55. Now if you don't know what the last term is, then a sub n, remember, is equal to a sub 1 plus n minus 1 times the common difference. And that's where you get the 2 a sub 1's in this formula. You'd have a sub 1 plus another a sub 1. And then you'd have the n minus 1 times d, and that's if you didn't know what the last term is. So that's how you get formula 2.
This is example 6, sum of arithmetic series. Find the indicated sum of each arithmetic series. We have s sub however many equals however many divided by 2 times a sub 1, which is -5, and then plus a sub n, which is 317. We need to find out how many terms are in this sequence. Well, a sub n is equal to a sub 1 plus n minus 1 times the common difference. So a sub n, the last term is 317, and the first term is -5. Then we have plus n minus 1. Now we need the common difference. If we take 2 minus -5, that's equal to 7, so the common difference is 7. Now we just need to solve for n. We have 317 equals -5 plus 7n minus 7. So 317 equals -12 plus 7n. Add 12. We have 329 is equal to 7n, and then divide by 7. So we need 329 divided by 7, and that's equal to 47. Now we know the n is 47. Now we need 47 divided by 2 times -5 plus 317, which is equal to 7,332. Find the 28th partial sum of 27 plus 14 plus 1, keep on going. Well, we know that we're finding the sum of the first 28 terms. So that's 28 over 2 times the first term, 27. Well, we really don't know the last term, so we can use that second formula that's given, formula 2. We can have 2 times a sub 1, which is 27, plus n minus 1, so 28 minus 1, times the common difference. We have 14 minus 27, that's -13, so times -13. So we have 28 divided by 2 plus 27 times negative 13. And that is negative 337. So negative 337. In the last one, we need to find the first term. So the first term is 5 times 6 minus 17. That's 30 minus 17. That is 13. So the very first term we have in this series is 13. So S sub something is equal to something divided by 2 times 13 plus, that's the first term, and now we need the last term in the series, which is 5 times 28 minus 17. 5 times 28 minus 17, which is equal to 123. So 123. Now imagine if this sigma notation looked like this. You're going from, let's say, 4 to 6. We would plug in 4, then we plug in 5, and then we'd plug in 6. Well, 6 minus 4 is 2, but yet we'd have 3 terms. Notice this. What if we had sigma notation and we had n equals 7 to 10? Well, yeah, we'd take 10 minus 7 and get 3, but you'd plug in 7, 8, 9, and 10, and it turns out there would be 4 terms. So if we're going to go from 6 to 28, we can take 28 minus 6, that's 22, but there's not 22 terms, there's actually 23 terms. So we're finding the sum of 23 terms. So we take 23 divided by 2. 23 divided by 2, and then times 13 plus 123. And the sum is actually 1,564.